So everyone, welcome for the third time. This is a talk about HTTP2. So I'm assuming that everybody that is here is somehow related to web development. Is that right? Okay. Also, I like to ask questions in my sessions, because that way I make sure that you're not asleep. And normally the questions are yes or no. Very simple. Or in Russian, da or нет. That's all I know in Russian. I have 3 kids, they're Russian, and I just say нет all the time. So, okay. So I'm your HTTP2. Obviously, it's also in English, so I'm hoping that you don't have an issue with that. I've been at the booth this morning, and every time someone comes up to me and I'm like, "Hi, can I help you?" They're like, "Oh no, go away." Like, I don't speak English. So anyway, I'll stand here. Okay. So what is this? As I said, it's about HTTP2. It's basically to give you an outline of what it is that you need to know in order to develop. Can we close the door maybe somehow, because I can't hear myself speaking? Yeah, thank you. It's basically to give you an idea of what it is that you need to know as web developers to get accustomed to going into the world of HTTP2. How many of you here are actually using HTTP2? Okay, great. How many of you are using Twitter? Right, so you're using HTTP2. And you didn't even know. It's fantastic, isn't it? So, how many of you are old enough to remember this? Come on, don't make me feel really bad. Okay, this was the World Wide Web in 1996. There was a website called Yahoo, and that's where you went to do things. Although back then you didn't do much. But you would go there and before Stack Overflow, we used to have this thing called Deja News, which was great. That's how we used to program in the old days. Now we do it with Stack Overflow. So you would go here and then you would get a bunch of links and some text, and you would just click on these texts and then it would take you to another page with more text, etc. And it was really, really fantastic. Now, since then, things have grown. You can see that the number of internet users have grown. We're approaching 3 billion users, more or less. Unfortunately, about 1 billion of them are on Facebook, contributing with amazing amount of knowledge and wealth to society. But anyway, but you can see that things have grown, and users by country. Oceania, which is Australia, New Zealand, is quite low. I've been there. It's extremely, extremely, extremely slow, which probably explains why it's so low. And we're somewhere in Europe and other places. We have evolved, though. We've had better user experiences and visuals. So this is, well, Yahoo's still more or less the same. Who uses Yahoo now? Who used it back in 1996? Oh, well, there you go. They didn't lose any users, did they? So this is more or less the same. It's got some nice pictures, but there are better user experiences. And when I was doing this session, preparing this session, I said, oh, let me Google, not Yahoo, let me Google new user experiences. And I went to a website which was called By Fantasy, which is a winner of some award. And what it does is basically this is a video, and you can see that what happens is like, let's find a doctor. So you start to search for a doctor, well, based on the illness. And then it kind of maps it out, shows little avatars of all the different beautiful doctors. And then you click on it, and then it tells you how to get to that doctor. Maybe you even books an Uber for you. Then, you can see each individual doctor, click on them, see their opening times, or see what reviews they've had, and then based on that, find the doctor that's more appropriate for you to deal with your illness and go to that doctor. Little side note, it's fantastic that it's all based on reviews. There was recently an article I read about a guy from a media outlet had created a fake company that he had called Fake. It stood for Freaking Awesome Karaoke Entertainment. And then Basically, for about $2,000, he had built up this company with fake reviews on all the best sites, including Facebook likes, everything, and people putting in amazing reviews, and he was ranked #1 in his sector. So, point being, this is great user experience, but don't trust it when you're looking for a doctor. But it's all good. Everything runs smooth. Everything's fantastic. So the question is, and right now, even people have more bandwidth. So you start to wonder, well, what's the problem? I mean, here, there's a law of Jacob Nielsen, which is similar to the law of Moore, that says basically, over the years, people are going to gain 50% more bandwidth. So year by year, we're going to have a growth. And if you see the plot of lines based on the actual, reality, he's not far off. Things are more or less going in this direction. Russia even has actually quite good bandwidth. I mean, until recently, I live in Spain, and you guys had way better bandwidth than I ever had. I just recently upgraded to 1,200 bits per second. But it's all good. If you take a look at bandwidth by country, you can see that South Korea is way at the top. Spain is way at the bottom, like always. France is somewhere in between, or lower. United States somewhere in between. And it's all good. Everyone's happy. You guys have good bandwidth, right? Yes? Yes. Just bear with me and say yes. Mobile networks. Europe. I mean, you imagine who would have thought on a mobile network, on a device, back in the old days when I first got my internet device, it was just like a tiny little Nokia screen, and it had a tiny little revolving world. Nowadays, you do everything on a mobile, right? In fact, they say if you don't do mobile first, you're dead. Don't even start a business. So given all this, the question arises like, why the hell are we dumping 1.1? I mean, if things are great, why are we doing this? And the problem, of course, is that it's no longer the bandwidth. Right? That is not the issue. The problem is the latency. And this is an article from May 1996 by Stuart Cheshire that wrote an article saying that the latency is going to be the problem, not the bandwidth. So people were like writing things back then as well. It's not just on Hacker News today, And the problem is the latency. And just to put us into context, everyone is familiar with what bandwidth is, right? Bandwidth is how wide my street is, and latency is how long it takes me to get from my home to my office. That's it. Basically, the distance I have to go. That's the difference. So at some point, bandwidth doesn't make sense because it doesn't matter if I have an empty street with 5, free roads. It's still going to take me the same amount of distance to get there. My car can only go at a certain speed. So the issue is the distance, right? Now, what is the distance limited by in terms of speed? What is it limited by? No, not sonic speed. A little bit faster. Speed of light, right? The fastest speed we will ever accomplish, maybe someone will, actually, this is a lie, because I'm sure that there's some company that will come out that will say, convince some venture capitalist in Silicon Valley that they're going to create something faster than the speed of light, and some VC will probably back it, because that's what they do. So, reality, though, now is that physics says to us that we're limited by the speed of light. So that basically means that to go from point A to point B, if we have in a vacuum nothing in between, we're limited to the speed of light. That's how fast it can go. That's how fast a fiber optic connection can go. Unfortunately, we also have other things in between. So that means that instead of, let's assume that there was nothing else in between from here to New York, it would take us maybe around 50, 60 milliseconds to get there. But since we have routers and other things in between, it takes us about 250 milliseconds to get there. Now, you imagine what I just said, and I want to pause for a minute there. It takes us 250 milliseconds to get from here to New York. 250 milliseconds. And yet, you're all here still thinking that that's a problem, that it's too slow. But anyway, if you take a look at the bandwidth and the page load time, you can see that as the bandwidth grows, the page load time reduces, but at some point it just stabilizes, right? So you get 9 megabits, 10 megabits, but it's starting to stabilize. Because, again, we're going to the problem of the speed, of the round trip that's going back and forth, right? So this is kind of a graph in terms of latency per bandwidth versus, and the page load time as RTT, which is return time trip. And you can see that there is a decrease when the latency decreases, when the bandwidth increases, it's just not that significant after a certain amount of time. And it is. And the problem is that the latency is per connection, right? So every time I open a connection, I get a latency problem. Here is a typical website. This is a newspaper in Spain. You open up Chrome and it shows you everything that it does. It basically makes a whole bunch of connections to all of these different servers. Most of them are probably the same server, but it's creating all of these different connections. And latency is per each of these connections. So this site, if you go to it, it takes about 60 seconds to completely load. Now that's quite slow. Fortunately, 54 seconds of it is adverts. So you can basically read what you want, and by the time the adverts are loaded, you leave. That's how we do advertising in Spain. So if you break down one of these, you can see that there's, this is the breakdown of a single connection. And look at, for instance, the content download here. It's 0.884 milliseconds. Look at the wait time, the request sent, the initial connection. And these start to build up over time. Now, if I have a single connection, it's okay, because all that increases at the end is basically that bottom part. It's the content download. The problem is that I don't have a single connection. I am actually doing this for each of those connections that I'm opening. Back in the old days, a web page just opened a single connection. Now it opens up 100, 200 connections. Have you ever used this page? It's called the web page test. You go to it, you enter your URL, and it gives you a beautiful waterfall diagram saying how basically everything is being blocked and why page loads are taking some time, right? So waterfall is a problem, not only in agile methodologies, but everywhere. If we take a look at the network, we have the OSI layers. How many of you know of the OSI layers? Brilliant. How many layers does the internet have? 5. Who said 4? There's actually a session in there as well, but there's 4. Physical link, network, 5. Physical link, network, transport, application, and session for SSL. So we've got 5, but the problem is this yellow one over here. It's all based on this transport thing over here, and that's the culprit. So basically what I'm going to tell you now is that HTTP doesn't have a problem. It's that damn TCP that's the issue, right? TCP has serious issues. Here's a simple echo server, right? All it does is just send back a single text. Look at what it's doing. Just a single text. I say hi, and I get all of these packets going across, right? Why? There's a bunch of things going on there. One of them is the handshake, the reliability caused by TCP, which we'll get into. Here's the first thing, handshake. Every time a new TCP connection opens, it does a 3-way handshake, right? Why? To create a reliable system. So it's basically the client says, I'm here, the server says, I'm here, the client says, okay, you're here, I'm here, let's go. And that's how every single connection starts. If you look back, you can see that 3-way handshake at the very top, right? And what's worse, that there's a 3-way goodbye as well. Now there's also this PSH and hack and all of these, and this is all of the reliability. So for every packet that's being sent, an acknowledgement packet is being sent back. There's also another problem with TCP, which is called flow control. Now, if you have one server here and you got another server here, or 2 machines and one is talking to the other, and you know the computing power of this one and you know the computing power of this one, and you start to send packets back and forth, and you know the exact bandwidth between these two, it's all fantastic and it's all great. You say, I'm going to send, I've got a 1 gigabyte cable, I'm going to be sending 1 gigabyte. Reality isn't that. Reality is that we've got multiple machines in between with networks, with different speeds, with routers, with different issues, with different buffers, etc. So what happens that TCP can't just say, we're going to start sending 1 gigabyte back and forth. TCP says, we're going to start with 100 bytes. Oh, it's going good. Let's do 200. Oh, it's going great. Let's do 500. Oh, something happened. Let's go back to 400. Right? This is called flow control. And it's to deal with congestion. And this microphone keeps going on and off, so I don't know if the people at the other side of the world are hearing me. So the problem is that flow control, again, is causing TCP delays, right? It's adding to that latency because every single connection starts with a very, very low buffer, the window. And as things go okay, it starts to increase that. Okay? So we're suffering from flow control issues, and we're suffering from, I'm just saying, if I'm holding this mic for holding it, then I'll just stop holding it. And to avoid congestion and the handshake. Now, back in the old days, we had HTTP 0.9 in 1991. What's missing there? Who can tell me? What? Doc type, content type, you mean? Yes. But apart from content type, headers are missing. There was actually no headers. Actually, you can't tell the difference anymore. Okay. So, there were no headers, right? So, given that there were no headers, everything was fantastic. You just sent something and you got some text back and everything was completely and utterly fantastic. It's just, I don't think it's working. 1996 came, and what they provided us were with headers, right? So now they said, oh, you can set back a user agent, and then the whole browser wars exploded because everyone wanted to have their own user agent. I could get back an accept header, which basically allowed me to say what type of document I want, etc., etc. Right? Okay. No, this one doesn't work either. So this was great, but again, this was done for an era where we just had a single text page with just some links coming back. Not for a single text page that's opening up 3,000 different connections. And what happened is that in 1.1 they added another thing which was called connection close. And basically what they did was, by default, it was open. So what would happen is that every time I would make a link, it would open a TCP connection, it would get the data, and it would close the TCP connection. With 1999 and HTTP 1.1, they said to us, now it worked. They said to us that what you can do is just keep that TCP connection open, right? So now I lost all of that overhead of the three-way handshake and the three-way goodbyes. I could use a single TCP connection to get a whole bunch of data back and forth. And that was brilliant. It started to add a lot of new possibilities. We had new optimization techniques. So we started to use a single connection. We now open a single connection, get index, get style.css, get any image, anything I want. Oh, absolutely great. We started to introduce this other thing called HTTP pipelining. How many of you have heard of that? Which basically means that I pipeline my requests. Instead of sending a single request, get the response back, another request, get the response back, I would say, take index, take style, take this, take that, send it, and then give it all back. Okay? But the problem is that this really had another issue. This had this problem called head-of-line blocking, right? Because TCP is a reliable protocol, it was causing HTTP to block previous requests until the first one came in. So the pipelining was actually causing more problems than solutions, and many browsers just dropped the implementation. But what we could do now is start to do multiple connections. So now I can have multiple connections to the same host, right? So that was actually excellent because now I could open multiple connections to the same host and get more data back and forth. Of course, we're developers, so what do? We screw things up. So we started to open up 3,000 connections, and the browsers said, no, we don't, because every TCP connection takes up its own resources, so browsers limited it to 6 or 8 connections. You go to a website, you open 6 dialog boxes, the 7th one will not open until one of them finishes downloading. So they limited it. What did? We hacked it. We did this thing called domain sharding, right? Because connections were limited to hosts. So we just created aliases, right? And we continue to screw things up. How many of you do use domain sharding nowadays? Right. You love it, right? But of course, domain sharding and other things also brought more DNS lookups. So while it adds some benefits, it destroys some others. And as I said, it creates still so many open connections on the client and server. Other techniques. Inline resourcing. How many of you use that in HTML? Where you basically can inline a resource so that when you make a request for an image, it doesn't make a new request for an image, but it sends it back in the actual HTML. What is the problem with that? First of all, we lose caching, right? There's no cache. It's over. It's gone. You know that beautiful thing we have a cache? No, it's gone. Next, encoding overhead, right? The contents is encrypted using base 64. That's a joke, by the way. Encryption isn't base 64. It's encoded using base 64, which also adds overhead. Another technique, concatenating and spriting resources. Concatenating basically means that I take a single JavaScript file or a single CSS file and send that back, and that's a concatenation of 60 JavaScript files that I have, or 60 CSS files that I have. And what that allows me to do is just send back a single request, get all the contents back. Of course, that also has its own issues because cache invalidation. You know, if I have multiple requests, that, you know, multiple files, one of them might change a single little thing in one of them, it's going to cause cache invalidation for the entire file. It also brought new problems, which we're having to deal with. I mean, if it wasn't bad enough having to deal with JavaScript, now we have to deal with grunt and gulp and all of these different things. Delay in processing. Because, of course, if I'm sending back a large file, one CSS might not render and the page might not display anything until the entire file comes back. Spriting. Spriting is a beautiful technique where instead of sending a single image, what you do is you create one large image that has all of your little images, and then you spend 6 to 8 weeks using CSS to try and position them, right? So that's a fantastic technique that we invented. I'm sure you all love spriting, yes? Yeah. The culprit, of course, as I said, is HTTP. It's TCP because of all of the issues that TCP has. It's not so much HTTP. HTTP is a chatty protocol. TCP wasn't meant for chatty protocols. TCP has the slow start and the head of line blocking. That, my friends, is why we have HTTP 2. It's not HTTP 1. It's TCP. Except they didn't say, you know what, let's just rip out TCP. We can't. It's kind of like, no, it's not going to happen. It's about performance. In a slide, in 3 words, it's about performance. That's what it is. HTTP 2 is about performance. Now, basically, what this means is that everything is going to get faster, except everything that you've done, which is going to get slower, which means you can undo what you've just done, which is fantastic because you can continue to bill your customers. In a few words, binary communication. So if you love doing a telnet and open up a port and say, oh, look what I have, it's beautiful, it's text, it's headers, and forget it, it's gone. It's gone. It's gone. I love text and it's gone. Compression and optimization techniques. It adds a few ability to compress your headers. Optimize, obviously, is binary. It's going to be faster as well because parsing binary is always faster than parsing text. So that is also introduced as part of the HTTP 2. The good news is that there's no change in semantics. So basically, all of the get, put, post verbs, all of these beautiful things that you have in HTTP 1.x continue to work. But it's not compatible with HTTP because it's binary and the other one is text. So how the hell does this work? But before I tell you that, let's answer the question. Is it speedy? How many of you have used speedy? Probably everyone here, right? You just didn't notice. No, it's not speedy. Speedy was a protocol that was developed by Google in order to make the web faster because obviously they have their interests in this. And HTTP 2 is built on top of speedy. So Google is deprecating speedy. In fact, there's a website that is called Can I Use? If you go there, speedy is not even used in Internet Explorer Edge. Of course, the other question is that who uses Internet Explorer Edge, but that's another thing. So it's not even supported in that, and in 2016 it'll be deprecated in Chrome. So by all practical effects, yes, this is built on the foundation of speedy, which is quite tested. HTTP 2 in a nutshell. Here is a header. I have the old part, which is like not the old part. That's the semantics of HTTP. I do a get index with HTTP 1.0. That part is going to map to what's called a binary, a frame, which has, a stream, which has a header frame or can have multiple header frames, and then it has data frames, which would be the data, the body of the request or the body of the response, right? So in the middle, there's some translations going on from text to binary. How do you do that, though? So there's 2 ways. One of them is H2C, which basically means clear text. So what happens is that a client, an HTTP 1 client or an HTTP 2 client, makes a request to an HTTP server. And it says, I want to upgrade. And it sends a header, which is upgrade 2C. And then it sends some HTTP 2 specific header settings. And the server, if it is successful, if it supports HTTP 2, will send back a 101, which is the status code 101, which means, what does 101 stand for? What? Upgrade request? No. I love HTTP status codes. I could go on all day. In fact, I have a talk that's just exclusively about HTTP status codes. Sorry, I got a boring life. It means switching protocols, right? So I'm switching protocols, I'm going to another protocol, which means this is not about HTTP2, this can be about any protocol. It sends back connection upgrade, and then it sends back upgrade H2C. If it doesn't, it just responds with a standard HTTP 1.1 status code, like OK or refused or whatever. Now, this no one's going to use, so just forget what I just told you. Everyone's going to use this, which is TLS. TLS is SSL, and ALPN is an extension to TLS, which stands for... Come on, I'm trying to be really smart here. Someone's got to say to me, no, I know what that stands for. It's Application Level Protocol. It's an N. Negotiation, right? Yeah. So that's an extension they've added to to TLS to allow for protocol exchanges, the protocol switches. And so it's going to work for HTTP2. And of course, in about 7 to 8 years, I estimate that HTTP2 is going to be a disaster. So we'll have HTTP3. Fortunately, this will support it. And what that does is basically on the three-way handshake, you also add the SSL handshake and then HTTP2 interjects here. Basically, what technology do we have today that allows us to do binary communication between 2 points? TLS, SSL. That's how it's going to work. Because we're already doing that. We're creating a point-to-point tunnel. Now, the reality also is why I said no one's going to use the previous one is because most browser implementations have said, and server implementation have said, if we support HTTP2, it's only going to be with TLS, right? They're going to have a serious issue in the United Kingdom because David Cameron wants to drop support for SSL. So, mental note, don't move to the UK. Single connection. This is very important. There's no longer multiple connections with TCP multiple connections in HTTP2. It's a single connection. On that single connection, however, I have multiple streams, right? Which kind of act as their own kind of mini connections inside this bigger connection. And these streams each have multiple entries which are called header frames. And there could be headers frame, there could be data frames, there could be settings frame, all of these different frames. If we break this down, a frame is a binary thing, and it's got a length, it's got a type, it's got flags, it's got an ID, and it's got the actual data. And one important thing there that you can see is the actual ID. And the reason for this is important. Because this ID is going to allow sequencing, which means it's going to allow multiplexing, which means that some of the issues that we had with TCP of like head-of-line blocking and pipelining is already now supported in HTTP2, right? Types of header frame, types of frame types, there's many. There's one of push, ping, all of those we'll see in a moment. So there's all these different types of frames that allow you to do all these wonderful different things. I think there's 10 if I can count correctly. Okay, there's one which is go away, which literally means just go away, leave me alone. This is a header frame. This is Wireshark. How many of you use Wireshark? That's the tool you'll have to get to love now. Good news is if you're using Mac, there's now a native client, so you no longer have to set up Linux and X window and Excel and then Quartz and then swear and hate everyone for having invented Linux and whatever. So you have the header frame. You can see here that I have like a header frame that's coming in. This is just a simple HTTP request. I have a header frame. And then what I have here also is a data frame, right? So the header corresponds to the header. Then the data corresponds to the actual data. It's doing that pairing. Now, as I said, it has proper multiplexing, which means that on a single stream, on a single connection, I can have multiple streams, and then these streams have interleaving different frames from different streams, right? So that allows me to, interleave requests and responses. And it's a bidirectional thing. And as I said, that is possible because now we have the sequencing, okay? And it eliminates head-of-line blocking, as I mentioned. So headers, here's another issue. If you see this is two requests to two different resources, right? Basically, everything is the same. We could play this game of spot the 10 differences between these two images. And really, everything is the same. Only a few things are changing. So yes, the URL is changing, then the e-tag value is changing, but a lot of the other things are remaining the same. And yet, every time you make a request, HTTP is sending this request. So what HTTP2 adds is header compression. It uses this really complicated protocol which has its own RFC, which is called HPAC. And what it basically does is maintain a state machine in the connection. And it only sends back patches. That means it only sends back headers that have actually changed. Okay? What this does is effectively reduce all the overhead that every single request response has. If the headers haven't changed, I won't send them back. You don't need to know anything about this. All you need to know is that it's complicated, and unless you want to implement HPAC, just say, yes, cool. It was initially using zlib, but then there was a hack against it by the name of Crime, and they said, okay, now we've got to do our own RFC. What it also defines is the ability to define priorities. So now streams can have priorities, which means that, let's say I have a web page, and on that web page I have an image coming back, and I have text coming back, and I have CSS coming back, and I have JavaScript coming back. I can start to define priorities for these resources. And I can say, you know, the images come last, and the JavaScript comes first, right? It allows us to now do these. And of course, a resource can have dependencies, so now you get this somewhat complicated graph of dependency of priorities, because every stream has a priority, which is its own priority, and then those that it depends on, and it's a beautiful little tree that you have to calculate. Fantastic, right? Really nice, and you'll see where I'm going with this. It also allows this other beautiful thing, which is called flow control, which, I just explained to you, right? Which is, since I can now do multiplexing, and since I can send streams, and since I can have like different priorities and different resources and different size of resources, I can now do things like window updates. So basically do flow control. So if you start to see what's happening is, whereas before in HTTP 1.x, we had to introduce a series of hacks to work around the lower level issues of the underlying protocol, HTTP 2 said, we're going to fix those hacks for you, but now we're going to bring the low level stuff of TCP up to you. Now, you don't have to use this, but we're developers and we like to screw things up, so we probably will. But effectively, it doesn't really impact you that much. It also has this other thing which is called server push. So let's say I go to a web page and I open that web page and I get requests for like CSS, JavaScript, and image. Now, I know that every time someone opens that web page, they're going to get those resources. So why not push that back to the client? When the client makes the initial request, I've got the stream open, I say, here, you've made this, let's start to push you these resources as well. The client no longer has to get those. It's being pushed to it. So it saves a request. And the client has the ultimate word. So the client can say, go away. I don't want to receive any server pushes. Okay? So it's basically replacing inline of resourcing, because effectively it's doing the same thing. And the server says, like, it sends the frame push promise, and then it allows for caching, and allows for cancellation by the client, etc. Security. Well, it's not forced, but given that the majority of the implementations are going to be on TLS, effectively it's all secure. That's if they don't hack SSL again. They did a couple of years ago, didn't they? So what's the current status? It's already out. It's already in RFC, right? So it's okay. You can start using it. And in fact, many sites that you're going to are actually using HTTP2. So the RFC came out in May 2015. It was 7540, and the HPAC one is quite complicated, so it has its own RFC. And if you go to a website, how many of you use this website, caniuse.com? So you go there, and we'll see it in a minute, and you go there and you enter HTTP2, and you can see that all of the browsers are now basically having support. Well, IE doesn't, Edge does, Firefox does, Chrome does, etc. Some browsers, earlier you would have to explicitly activate HTTP2. I think by now most of them probably activate it by default. So if you type that with Speedy, you'll see that there's less, Edge is no longer supporting Speedy, and Chrome will eventually drop it. I'm guessing that Chrome is what? A number, when I took this screenshot, it's at 48. Probably now it's probably at 78. So by next year, it'll be about 132. So version 135 of Chrome will probably drop that. Don't put that on the record, obviously. What about server support? H2O, Akamai Edge, Apache, Jetty, Wildly, no, it's Wildfly. Nginx and IIS in Windows 10 and Server 2016 are going to support HTTP2. Most of you here are .NET. Well, given that it's a .NEXT conference, I'm guessing majority of you here. Okay, who's not a .NET developer? No, not. Okay. JavaScript? No. Java? Awesome. There's more support in Java than there is in .NET. Go Java. So, no, Java is good. No, Java as a language sucks. Platform's awesome. And in fact, I've got some, if you're interested more about Java, I cover it at the closing keynote today, so stop by. Client and library support, Jetty, which is kind of like a container technology, kind of like ASP.NET/MVC, blah, blah, blah. Then there's Netty, which is faster than Jetty. Then there's curl, and there's OKHTTP, which are well, curl is a command line URL. That already has support for HTTP2. Tooling. What can you use to start to work with HTTP2? You have curl, as I said, you have Chrome tools. You have Wireshark and you have Web Page Test. Well, Web Page Test is not about HTTP2 as such. I mean, you can see the performance differences, but it's about seeing the performance of pages. Now, Wireshark is basically the same way that you would decipher SSL, add support for SSL in Wireshark. You can now use that to do decrypting of the packages of, seeing the packages of HTTP2. Let me show you a couple of demos very quickly. So if we go to Akamai, right, what will happen is that the browser will open up and the connection is really fantastic. So here, so it says you are using HTTP2 right now. If your browser wasn't supporting that, it will say you're not supporting HTTP2 right now. You say click here for a demo. And this is fantastic because 9 out of 10 times that I run this, HTTP2 is slower than HTTP1. But you can see that what's happening is that basically it's loading all of these thousands of little images. Now this is a good demo because this is effectively what happens in a web page, right? I'm loading multiple resources continuously. And this works really great because it's on a really slow connection, right? So you can see that fantastic demo. Give me a round of applause, please, people, given that I didn't do anything. You're too kind, I didn't do it. But you can see that, like the latency, right? The load time is 4 seconds, latency is 443, on the other one is 734. I won't run the other demo because I don't want to impact the demo gods, but it's, oh, okay, let's run it. So here is the other one, and it does basically the same thing. So you can see HTTP 1.1, and then you say run HTTP 2 test, and you can definitely see that it's faster, okay? So that's basically what it's doing. When I have multiple connections coming from different streams, obviously each connection that comes from a different host is a different connection. But to the same host, it's a single connection. It is getting those resources in a much faster way. So how does this affect our applications? Now the good news is it doesn't. So bad news is you just wasted 40 minutes of your life. Really, you don't have to do anything except undo everything you did. It's mostly transparent. If you're doing web apps, like really there isn't much stuff except de-optimize. Because multiple TCP connections are no longer required. Domain sharding is no longer required. Concatenation and spriting is no longer required. And that really is good. That's like a good thing. Yeah, that's one of the pain points. And inlining is no longer required. So all of those hacks that we did are no longer required. Now we can spend our valuable time hacking HTTP2 and screwing things up. APIs. Well, since it's semantically the same, it's HTTP as the protocol. So there is no change. I still do get, post, put, delete. All of these same things happen the same way. So but there is like no concern about chatty APIs. Now a lot of people, when they're doing this kind of HTTP API endpoints, which I won't call REST because they never are, But if they're doing, for marketing purposes, if you're doing a RESTful API, then what happens is that some people worry that they have like these very, what do you call it? Finely grained calls. And that's the wrong thing to do anyway, right? You don't actually push your business logic via HTTP calls. You should encapsulate your HTTP logic in a single call. But one of the issues that people would work around that is like saying, oh, because I open up multiple HTTP connections. Now you don't have that issue either, right? From a library API, as I said, semantically it's the same. So I still use it the same way. Unless I'm doing something like low-level working with priorities, queues, frame, compression, etc., there is really no change. It's still semantically the same as HTTP 1. That's why the browsers, all the websites, and all of these things work. Well, OK HTTP and Netty basically are a couple of demos. I mean, I can show you, but it's really just showing you the code that is exactly the same as it would be in 1.1. Now, like everything in life, it's not all roses. What it's basically doing, if you've realized, is adding transport level complexity to application level complexity. What that means, of course, is you don't have to mess with these things. But you all know, and I know that we will, right? So when we start to do all of these different things with priorities, etc., we have to be aware of the potential issues, right? No one's really done flow control management, yeah, at TCP level. And Speedy, no one's done this because Speedy didn't really surface these concepts, whereas HTTP2 is now surfacing it. So you have to deal with priorities, deal with flow control. How will push really work? Again, it's not something that's been out there in the wild for so long. HTTP2 is starting to pick up. The RFC was only published this year. Using it, we don't know how it's going to work out. I don't know how it's going to work out. How push will really work. Okay, so there's a lot of things that can potentially happen that we're not aware of. But only we will know that when we start to investigate with it more and play with it more, etc. If you want more information, a very good starting point is HTTP on GitHub, HTTP2. It's got the protocol there, it's got the RFC links, it's got demos, it's got links to libraries, servers, all of these things. And also, I don't know if any of you have read this book, High Performance Browser Networking by Ilya Grigorik. Anyone read it? Highly recommend you read it. A lot of the stuff that I've been talking about here is covered in this book. While it does not have in-depth knowledge of HTTP2, he did add a chapter to it. The best place for getting more knowledge about HTTP is the RFC protocol itself. But it does cover all of the techniques that we've been speaking about and all of the issues that are highlighted in TCP. That's it. Thank you very much.
Есть вопросы?
Yeah, thank you for this presentation. So, help me understand. I am a .NET developer. I'm writing websites. I'm writing quite a common ASP.NET MVC website with bundling. You love it. We bundle CSS into one bundle and deliver it. We bundle JS into one bundle and deliver it. So just like you described, yeah. Okay. Next day we switch to HTTP2. Will my bundles be pushed?
No. No.
So how do I enable pushing, or is it a native functionality of IIS?
So pushing you have to enable, right? And so the application server or the host container has to have support for pushing. And it's basically done via HTTP2 headers. So there's headers that you can set which are specific to HTTP2 to enable pushing. However, even if you were to push it, really what you're doing there is just saving on a simple request, right? But you're still bundling everything. And since you're bundling everything, you're losing some of the other things that you're losing by bundling, right? All of the caching, all of these things. So the question now arises is, what should I do? Well, as I was mentioning is, there is a process of de-optimization. But the problem is that if you de-optimize, how are you going to cater for clients that don't support HTTP2? You get my drift? Charge more to the customer.
Thank you for your speech. Probably I didn't follow the first part of your speech, but my general question is who develops and maintains such standards? And there is the ability to, for mortals to introduce new features, new ideas into such standards. Thank you.
Like all RFC, it's basically a standards committee, and it's formed by a couple of engineers at Google. It's formed by engineers at Akamai. Mark Nottingham, I don't know if you've heard of him. He's one of the main guys. Ilya Grigorik also participates in this. Obviously, it's mere mortals, but I don't know. I mean, you know, it's a standard, just like any other RFC has been proposed. If that's your question. Yeah, so it's not a single company. It's basically a standard like all our other RFCs. Well, it's by the Internet Engineering Task Force, right? So it's by the global organization that oversees all of our lives. Effectively, they do, right? I mean, would you have a life without internet right now? No, right? By the way, if we're running out, because we've got 1 minute. I'm going to be at the booth after this, if you have any other follow-up questions, if there is no time.
Thank you, Hadi.
Okay.